see a Cauchy Residue Theorem problem. So our problem is evaluate integral over c e power 2 z plus 2 into z plus 1 the whole square dz, where c is the circle modulus of z equal to 3. So c is the circle modulus of z equal to 3 means a circle which is having 3 as a radius. Okay. Now we have to find out the similar points. Those are the poles which is inside the circle. So we have to find out that. Okay. Let's go to the sum. So let f of z equal to e power 2 divided by z plus 2 into z plus 1 the whole square. This is the given f of z. So from this f of z we have to find the pole and order. First of all, the Cauchy residue formula is integral over c f of z into dz equal to 2 pi into sum of the whole residues. So we have to find the residue formula for this. So to find residue formula, first we have to find pole and order of the equation. So the equation is z plus 2 into z plus 1 the whole square, which is equal to 0. So we have to find for what value this equation becomes 0. We have to find that. Putting z equal to minus 2, we get that equation equal to 0, and then putting minus 1, we have to find the equations for the whole for this equation. So z plus 2 into z plus 1 the whole square equal to 0. So by putting minus 2 in this equation getting into 0. By putting minus 1, we are getting this equation into 0. So these values minus 2 and minus 1 are the poles for this equation. So we are consider the pole as a z0. So z0 equal to minus 2 and z0 equal to minus 1. Z0 we are putting here. So the order of this equation is 1. Here nothing means it's 1 is here. So m equal to 1. So by putting z0 equal to minus 1, we are getting our order as 2. So mentioning our order as m equal to 2. So now we are going to find the residue for this. So the condition for the residue is our poles must be inside the circle. So z equal to minus 2 and minus 1. So modulus of z is 1 and 2. We know that radius must not be in the negative. So we are considering the modulus value for this poles. So the modulus value is 1 and 2. 1 is which is inside the circle, which is less than 3. So it's inside the circle C, and 2 is also less than 3, which is lies inside the C. So now we are going to find at m equal to 1. So m equal to 1 means the pole's value is m equal to 1 is z0 equal to minus 2. We are going to find that. So residue of f of z equal to the formula for at m equal to 1 is residue of f of z equal to z0 limit z tends to z0 z minus z0 into f of z. So our f z0 is minus 2 here and m is 1. So limit z tends to minus 2 z plus 2 into e power 2. Our f of z is e power 2 into z plus 2 into z plus 1 the whole square. So we are getting the term cancelled. So limit z tends to minus 2 e power 2 divided by z plus 1 the whole square will come. So applying the limit value z tends to minus 2. By putting minus 2 here, we will get minus 2 plus 1. As a result as minus 1. So minus 1 the whole square will become 1. So e power 2 divided by 1. We will get e power 2 as an answer. Then next one, at m equal to 2, the formula for the residue is residue of f of z equal to z0 equal to 1 divided by m minus 1 factorial limit z tends to z0 d power m minus 1 divided by d z power m minus 1 z minus z0 the whole power m into f of z for m equal to 2. For, this formula is for m is greater than 1. So residue of f of z at z equal to minus 1. So our z0 here is minus 1 and our m is 2 here. Applying the values in this formula, we are getting 1 divided by 2 minus 1 factorial limit z tends to minus 1 d power 2 minus 1 dz power 2 minus 1 z plus 1 the whole square, and then our f of z given the function e power 2 divided by 1 the value. So we are getting cancel these values. We are getting e power 2 divided by z plus 2. We know that d by dz of this term is equal to d by dz of z plus 2 the whole power minus 1. So by differentiating this, we will get the formula is x power n equal to n into x power n minus 1. So minus 1 into z plus 2 power minus 1 minus 1. So we are getting minus 1 divided by z plus 2 the whole square as an answer. So limit z tends to minus 1 minus e power 2 divided by z plus 2 the whole square. By applying the limit value, we are getting applying minus 1 here, which implies minus 1 plus 2 the whole square, which implies 1 the whole square equal to 1. So minus e power 2 will come. We know the formula for the Cauchy residue, 2 pi into sum of the whole residues. So the first value is e power 2 and then second value is minus e power 2. By adding both this, we will get 0. 0 into anything equal to 0. So the value of the Cauchy residue for this function is 0. That's it. Thank you.